All right, today in Algebra 2, we're going to look at section 6.5, the properties of logarithms. So let's scroll down here to our properties. So it tells me that for positive numbers b, m, and n, as long as b is not equal to 1, the following properties hold. These are properties that you will want to memorize. So the product property of logarithms says that the log of base b of m times n is equal to the log base b of m plus the log base b of n. So two logarithms added together that have the same base, all I have to do is multiply. I can write that as one logarithm, multiply the two things that they were asking me to take the log of. The quotient property of logarithms said that the log base b of m divided by n is equal to log base b of m minus log base b of n. And then the power property of logarithms tells me that the log base b of m to the nth power is equal to, so my exponent comes out in front of my logarithm, so that would equal my exponent n times log base b of m. So first we're going to prove some of these properties. Don't worry, we're not going to do proofs like geometry proofs. Okay, we're not looking at two-column proofs. So the very first one just says prove the product property of logarithms. In order to do this, we're going to let x equal log base b of m and y equal log base b of n. Okay, that way I can just write x and y and I don't have to write out the huge logarithm each time. Then I could say, if I change the first one, x equals log base b of m, if I change that to an exponential, then I have b to the x power equals m. And I change the second one to a log or to an exponential, I would have b to the y power equals n. So now I'm going to multiply these two together. So b to the x times b to the y is going to equal m times n. So just multiplied bx times by, and then the other sides, multiply those, m times n. So now our properties of exponents, we know that these two have the same base b. I add my exponent, so b to the x plus y equals mn. So now I'm going to write the logarithm of both sides. I'm going to put the log back on both sides. So this would be log base b to the x plus y equals log base b of mn. Log base b of b, remember all of that has the same base, so that's really just 1. It goes away, so I'm left with x plus y equals log base b of mn. Now I'm going to replace x and y with what I said that they were equal to. So x, I said, was really log base b of m, plus y, we said, was log base b of n. That equals log base b of mn. So we just proved the product property. Now we're going to do the exact same thing with the quotient property. We're going to prove that. So again, I'm going to let x equals log base b of m and y equal log base b of n. I'm going to change them to exponentials again. So b to the x equals m, b to the y equals n. Now I'm going to divide them. So I'm going to say b to the x divided by b to the y equals m divided by n. Again, using our properties of exponents, they have the same base, but I'm dividing them, so I subtract my exponents. So this would say b to the x minus y equals m over n. Again, take the log of both sides. So log base b of b to the x minus y equals log base b of m divided by n. Again, log base b of b is just 1. So really I just have x minus y equals log base b of m divided by n. And again, my final step, I'm going to substitute back in my x's and y's. So x was really log base b of m minus y was really log base b of n equals log base b of m divided by n. So we just proved the quotient property of logarithms. All right, so now we're done proving. We're going to start using these properties. So the next page of notes, it says expand the logarithmic expressions. Use your properties of logarithms to expand. So number one, log base 5, a squared, b to the 7th. I have two terms, a squared and b to the 7th. So I should have two logarithms written down. First thing we're going to do is the multiplication. A times b, so that means I add the two logarithms. So I would just say log base 5 of a squared plus log base 5 of b to the 7th. Now the last thing that I have to do is my power property of logarithms. So these exponents come out in front. So a squared, that 2 comes out front. And I say 2 log base 5 of a. Plus here my 7 comes out front, 7 log base 5 of b. I've just expanded that logarithm. Number 2, the natural log of 25 divided by 3. Again, I have two terms, a 25 and a 3, so I'm going to have two logarithms. So this is really the same thing as the natural log of 25 over 3. We can rewrite 25 as 5 squared over 3. So this is really the natural log of 5 squared minus the natural log of 3. Now use my properties of exponents. So that 2 comes out front, 2 natural log of 5 minus the natural log of 3. So if I can rewrite any of my numbers as a power, we want to go ahead and do that. Number 3, log base 7 of r cubed t to the 4th divided by v. I have 3 terms, so I'm going to have 3 logarithms. If we can do this all in one step, okay, let's try that. So now on top I have r times t, so I'm going to be adding those two. And then divided by means I'm going to subtract a logarithm. But I have exponents. Those exponents come out front. So I'm going to have 3 log base 7 of r plus 4 log base 7 of t minus, okay, so this whole thing, minus log base 7 of v. Right, number 4, the natural log of 7 divided by 25. Again, let's see if we can rewrite this. So this is really the natural log of 7 over 5 squared. So the natural log of 7 minus, that 2 comes out front, 2 natural log of 5. Right, so now we're going to see if we can go backwards, and they're going to have it expanded out, and we're going to condense it. We're going to write the logarithm as a single logarithm. So use the properties of logarithms to condense or write as a single log. Number 1 says 4 log base 4 of m plus 3 log base 4 of n minus log base 4 of p. So these numbers out front came from exponents. This plus means we multiply, this minus means we divide. I'm going to have one answer, log base 4 m to the 4th times n cubed, all that divided by p. There's my answer. I can put all of this in parentheses so I know that I'm taking the log of all of that. Number 2, 3 natural log of 2 minus 2 natural log of 5. Again, numbers out front came as exponents. So this is really natural log of 2 cubed. Minus means divided by 5 squared. Then I can work out those numbers. So this is really the natural log of 2 cubed is 8 over 5 squared, 25. So there's my answer. Number 3, 5 log base 2 of c minus 7 log base 2 of n. So I know I'm going to have a log base 2, c to the 5th divided by n to the 7th. All of that in parentheses. And number 4, natural log of 7 squared times 2. So this is the natural log of 49 times 2. I can rewrite that. I can go ahead and multiply 49 times 2. That's the natural log of 98. So we've looked at expanding and condensing them using those properties. Now let's see if we can apply those properties of logarithms. So our first word problem, it says the pH of a solution is a measure of its concentration of hydrogen ions. This concentration measured in moles per liter is written, okay, and then we have the H plus in brackets. And it's given by the formula pH equals log of 1 divided by bracket H plus. Our question, what is the concentration of hydrogen ions in the acid rainfall? Here they show me acid rain, pH is 4.5. So we simply want to plug in 4.5 up here. 4.5 equals the log 1 over, and then my H plus. I need to get this H plus by itself. I'm trying to find that concentration of the hydrogen ions. I have log of two things over here being divided, so I'm going to expand this out. So this is really going to be 4.5 equals log of 1 minus the log of my hydrogen ions, so H plus. So now I'm going to work this out, 4.5 equals, so the log of 1, if I type that in my calculator, that's 0 minus log of my hydrogen ions. So I have 4.5 equals negative log hydrogen ions. I'm going to divide both sides by that negative, and so then I get negative 4.5 is equal to the log of H plus. Now, in order to solve a logarithm like this, I'm going to change it to an exponential. So I would say 10 to the negative 4.5 is equal to H plus. So I could say my hydrogen ion, the concentration, is equal to 10 to the negative 4.5 moles per liter. Or I could go ahead and work that out and type in 10 to the negative 4.5, and I find out that that is approximately 3.16 times 10 to the negative fifth, again, moles per liter. You just need to recognize that these are both the exact same thing. Okay, let's try that again. And so the next one says, what is the concentration of hydrogen ions in a liter of orange juice? So we go back and we look at orange juice, pH is equal to 3. So I'm going to say 3 is equal to log 1 plus my hydrogen ions. Again, using my properties, 3 equals log of 1 minus the log of my hydrogen ions. Again, I know that log of 1 is 0, so I get 3 equals negative log hydrogen ions. Divide by negative 1, so I get negative 3 equals the log of my hydrogen ions. Change to an exponential, so I get 10 to the negative 3 equals my hydrogen ions. So I can say the concentration is 10 to the negative 3 power moles per liter. Or I can say that concentration is approximately, so if I put that in my calculator, approximately 0.001 moles per liter. So that's how we can use these properties in the real world. The last thing that we want to talk about is evaluating logarithmic expressions using the change of base. Okay? So in order to evaluate logarithms other than base 10 with the calculator, we must use the change of base formula. For positive numbers m, b, and a, as long as b and a are not equal to 1, this is the change of base formula. We need to memorize this. Log base b of m equals log base a of m divided by log base a of b. So number 1, it just says evaluate using the change of base formula. Evaluate means we want a number for an answer. So I have log base 2 of 3. As it is, I cannot put that in my calculator. So if I use the change of base formula, I take the log of my number that they're asking me to take the log of, divided by the log of the base. Then I can type that in my calculator. So now in my calculator, I'm going to type log 3, get an answer. Divide that answer by the log of 2, and this is approximately 1.58. So number 2, log base 2 of 7, I would say log 7 divided by log 2. That's what I'm going to type in my calculator. When I do that, I get approximately 2.81. And number 3, log base 5 of 3, I'm going to do log of 3 divided by the log of 5. And I find that that is approximately 0.68. So now you know how you can use your calculator to evaluate any logarithm, because now we have the change of base formula. So now we can solve using the change of base formula. So number 1, 2 to the x equals 7. Put it in log form. So put in log form. So that means when we've learned at the beginning of this chapter, okay, we've learned how to change a logarithm to an exponential and an exponential to a logarithm. So I want to first thing, just change this to a log. So 2 to the x power equals 7 is really the same thing as log base 2 of 7 equals x. Now, log base 2 of 7, right? Using our change of base formula, I can now say x equals log 7 divided by log 2. So there's my answer in log form. Now we're going to evaluate that. So we'll go ahead and type that into our calculator. So x is approximately 2.81. So this is in log form. This is approximating. We can always check our answer, right? So I can always check it. So 2 to the, I'm saying 2.81 power is approximately 7. And yes, that works out. Let's look at one more of these. Number 2, 3 to the x equals 15. So again, I'm going to make this say log base 3 of 15 equals x. Change of base says log 15 divided by log 3. So this is my answer in log form. Now I'm going to approximate it. Type that in my calculator. Log 15 divided by log 3, I get x is approximately 2.46. I can check it. So 3 to the 2.46 power is approximately 15. Yes. All right, so that takes care of section 6.5. Our homework today is our 6.5 worksheet.